Okay, let's get into this. We're tackling a pretty universal problem in professional AV today.
Mm-hmm.
How do you manage the old stuff? You know, the legacy signals inside a massive modern system.
Yeah, the things that just refuse to die.
Exactly. So for this deep dive, we're looking at the architecture of the WolfPack Composite Video Output Card, the CVBS.
And this is purpose-built for those huge modular matrix switchers. We're talking 9 by 9, 18 by 18.
All the way up to the 36 by 36 units. It's pretty wild.
It really is, because you're looking at a card that specifically handles 480p video, a standard most people probably think is, long gone.
But it's not. It's mission critical in places like casinos or big sports bars. The system just has to work across everything.
Reliability is the whole game there.
Which brings us to modularity. This card, it's about $250 for a single port. And it just handles this one old signal. That seems a little steep, doesn't it? I mean, why not just use a cheap converter box?
Because what you're really buying is uptime. This is true plug-and-play switching right in the mainframe. So if an output fails, you're not shipping a giant heavy chassis back. You just pull that one $250 card out, pop a new one in.
And you're back up and running.
Instantly. And that's backed by their 2-year WolfPack Care warranty. They'll usually get you a replacement in 24 hours. When a casino has thousands of dollars on the line for one screen, that price makes a lot of sense.
Right. But that modular design, it also introduces a risk, doesn't it? I saw a really critical warning about mixing signals.
You did, and it's a big one. You absolutely cannot combine the 4K60 cards with this 480E card in the same chassis.
A necessary separation, I guess.
It is, but here's where it gets really cool. The performance. This card boasts 100 milliseconds seamless switching. That's a tenth of a second. Which
is incredibly fast. Most non-seamless switchers, you get that ugly black or blue screen for a few seconds.
And that completely breaks the experience if you're watching a game. That 100-meter speed means the viewer never even knows a switch happened.
So how do they do that? How do you get a switch that's flicker-free? I know it involves ED-die hops and HDCP handshakes.
It does.
For anyone not deep in the weeds, what does executing simultaneously actually get you?
It's basically preloading the information. The engine makes sure all those digital negotiations happen at the same time. It uses a frame buffer to hold the input signal, so it's like setting up the next picture before the cut actually happens.
It's always one step ahead.
Exactly. That's what gives you the fastest possible output without any interruption.
And they've thought about the audio, too. It has 3.5 millimeter support, so you can de-embed the audio on the way in or embed it on the way out.
Yep. Full flexibility. And for handling the different resolutions, there's an 8-pin DIP switch right on the card.
A manual override.
A crucial one. It lets a tech on-site manually force that old 480i signal to scale perfectly for a modern screen. A real problem solver.
All the tech agility has to translate to control, right? I assume it works with the big third-party systems.
Oh, yeah. You've got your front panel buttons, the WBBGI, the mobile app. But for those huge 36 by 36 setups, it's all about RS-232 integration with AMX, Control4, Crestron, all the major players.
And the commands are simple.
Incredibly simple. Let's say you want to switch input 8 to outputs 1, 8, and 16. The command is just by 1, 8, and 16. With a period at the end.
That's it.
That's it. The matrix just replies, OK, or ERR. It's built for speed and efficiency.
And you see this architecture everywhere. Sports bars, casinos, data centers, even places of worship and schools.
Any place that needs reliable routing for a mix of old and new signals.
So what it all comes down to is speed, modular reliability, and really smart control integration. This is a fantastic deep dive into how you keep legacy gear not just alive, but thriving.
It really is. The R&D on this MAV card concept was all about solving uncertainties and being ready for future upgrades. So that makes me wonder, and maybe something for you to think about, given this trend, what low-res or specialized signal that we use today do you think will be the next one that needs this kind of dedicated modular support in the future?